Here's a beaker of water, and I am going to put some baking soda into the water because water itself does not conduct electricity. And I want this water to conduct electricity in this demonstration. So I'm going to go ahead and stir this baking soda in. The baking soda is just going to allow the water to conduct electricity, and that's its only purpose. This device is called a Hoffman Apparatus, and I am going to put the water containing the baking soda into the Hoffman Apparatus. To do that, I'm going to take the beaker of water that I prepared, and I'm going to pour it into the top here until it fills up both of the tubes on the side. They are all connected. And so as you can see, the water is going into the Hoffman Apparatus in both the left, the right side, and the center. And I'm going to fill it up until I get to those valves up at the top, which is just a little bit more. There we go. I'm now going to seal these valves so that nothing can escape out the top through the two valves. I'm also going to hook it up to this DC power source. DC stands for direct current, meaning that the negative always is negative and the positive is always positive. If it was AC, alternating current, then it would switch back and forth between positive and negative. But right now, with this DC power source, I have the negative electrode, the black one, hooked up to one side of the Hoffman Apparatus, and the positive electrode hooked up to the other side of the Hoffman Apparatus. I'm now going to turn on the DC power source by pushing the on switch here. And when I do that, watch what happens down here at the bottom. So you'll notice that there is something going on. I have some bubbles being produced out the electrodes of the Hoffman Apparatus. The bubbles are bubbling up to the top. Because I closed the valves at the top, these bubbles cannot escape out the valves, and so we will collect the gas that is being produced at each electrode in this Hoffman Apparatus. We'll also be able to measure how much gas is produced because we have graduations on the Hoffman Apparatus. So we'll be able to measure how much gas is being produced at the negative electrode and at the positive electrode. It has been about 4 minutes, and you'll notice that there are still bubbles being formed here, gas is being formed. I put a background behind the Hoffman Apparatus so you can see these bubbles just a little bit better. Also, if you'll notice on the negative electrode, you can see how much gas has bubbled up into the graduated cylinder. Over here, you'll notice how much is bubbled up on the positive electrode. So, was your prediction about the amount of gas at each electrode about right? We're going to continue to run this and see what happens after a few minutes. It's been about 20 minutes now, and I thought I'd let you see what's going on and where we are at this point. Notice, again, the negative electrode, how much gas has been produced, and the positive electrode, how much gas has been produced. So we'll let this run a little bit longer and see our results later. Okay, it's been about 30 minutes, and you can see the two tubes that contain the gases that were collected. And if I put some white paper behind there, you can see how much of the gas was produced. So notice it's measuring from the top down because the gas filled the tube from the top down. And if you'll notice, there's about 9 milliliters of gas over here in the negative electrode side. On the positive electrode side, you can see, again, it measures from the top down. And put the white paper in front, and we'll see how much was produced here. Notice that is about 4.5 milliliters. So a 9 to 4.5 ratio here. Hopefully you can reduce that to a whole number ratio and see how the two sides compare to one another. So our last thing we need to do is test each gas for how they behave in the presence of a flame. So to do this, I am going to use a test tube, which I'm going to hold at the top of the negative side. I'm going to let some of the gas out into the test tube. The water from the center tube is going to push the gas out of the top of this side. So I'm going to go ahead and turn the valve, and I've collected the gas in this tube. And now we want to test it. We want to see what happens when it's exposed to a flame. So I'm going to go ahead and light this, and we'll see what happens when I expose it to a flame. All right. The next one, I'm going to collect off of this side. And for this one, I'm going to do it a little differently. I'm going to hook a tube up to the top, and that way the gas will flow through the tube here, and I will put it into a test tube just like this. So we're going to see what happens when I do this. Now this one's going to be a little bit different, but let's go ahead and turn the valve. You can see the gas moving out of the tube through the valve, and it's going into the test tube. All right. So I'm going to go ahead and stopper that with my finger. This time I'm going to take a wooden splint, which I'm going to light. And we're going to see how this wooden splint behaves when I put it into the gas that I collected in this tube. So watch what happens when I do this. I'm going to go ahead and shake this out. Well, that wasn't what's supposed to happen, and I'm out of gas. What should have happened, and I just didn't do it properly, what should have happened is when I put the burning splint in, it should have actually relit the wooden splint. It would catch on fire even more, but it didn't do that, so that was definitely a mistake of mine. I didn't collect the gas very well. So I'm sorry you didn't get to see that, but you should have seen the gas actually caused the wooden splint to catch on fire again. You wouldn't hear anything like the first one. You would only see the splint catching on fire again. So that's our demonstration. So now we got some questions about this to discuss. Thanks for watching.